Okay, I assume everything is working. Hello, everyone. It's apologies for the 2 minutes delay. We had a small technical problem. It's my pleasure to welcome our speaker today, Efthimios Harokopos. And before we get into the presentation, I just want to make a few. I'll introduce the speaker. Before that, I will make a quick announcement. This is a new format, so for the IPI members, you should have received a link to a Teams chat room. The plan is to reconvene after the live streaming and have a Q&A session with our speaker and myself and all the interested IPI members exactly at the end of this presentation. So when we finish the live streaming, go straight to the chat room and we reconvene there. This is for IPI members with a link. Regarding today's talk, once again, it's a huge pleasure to welcome our speaker today, Efthimios. He has a beautiful bio, a beautiful life profile. He studied mechanical engineering at State University of New York, Buffalo. He did receive his BSc and MSc degrees from this university. And then I guess he spent a lot of time in the United States, many years. And then he went on to work in electronics and robotics at AT&T. During this time, Efthimios enrolled at Columbia University into a PhD program in engineering, and he completed all the coursework for this PhD program. But he decided to make a move to the glamour of Wall Street, and he received a second MSc for all this work because he decided to move to Wall Street. Efthimios is a very interesting gentleman. He has a deep passion for philosophy of science. He's doing independent research in the nature of reality, the impact of digital technologies on human life and evolution. He's also running and posting on his blog called Digital Cosmology blog quite frequently. I believe I met Efthimios privately a few days ago, and he's, as far as I understand, he's also running a small data mining company in his spare time. And today we have the pleasure to host Efthimios for our IPI Talk. He recently became a IPI member as well. So welcome, Efthimios. The title of your presentation today is the virtual reality hypothesis. And I will let you, sir, welcome. Welcome. It's an honor to have you live and doing this talk for IPI. I'm going to mute myself and allow you to share your PowerPoint presentation and start as soon as you can. At the end, I'll just step in at the end again to thank you, and then we meet in the chat room to debate this presentation. How is that for a plan?
Yes, thank you. It's my honor to be here, and thank you for the invitation. I also greetings to the attendees, real time, and also those who will watch the presentation in the future. And I would like to start by saying that this virtual reality hypothesis is very intriguing, and the topic of my talk is from Parmenides to Einstein and beyond. Before we start, we have to acknowledge the pioneers of the digital physics movement. We start from Konrad Zuse, and according to some people, he was the one who developed the first truly programmable digital computer in the Second World War, during the Second World War in Germany. And then he started a company after the war, and that company was bought by Siemens. He wrote a book, Calculating Space, where he discussed the universe as a digital cellular automaton, like computation, and all the other people you see here, and Wheeler, it from bit. This idea of a computational universe didn't gain much traction until the 1990s, late 1990s, probably because of the explosion in computer power and computers becoming mainstream, becoming personal computers, and people start talking about again about virtual reality, computational universe, and the simulation hypothesis. Now, I'm going to clarify that I don't like the term simulation, because what we see is a reality. This is a reality. It's not a simulation. It's the only reality. And but the term is simulation generates clicks, as we say today, in social media and for mainstream media. So they love the term. It scares people. They wonder if they are avatars in some kind of alien simulated reality or ancestor simulations. That's the reason I don't like the term. I also am not very keen on virtual, but the term is used by physics, virtual particles, so it's okay in some way. My talk has two parts, philosophical foundations and my hypothesis and experiment for what it is worth. Why philosophical foundations? Because in the 1990s, late 1990s, beginning 2000s, the simulation hypothesis became popular. I was wondering at that time whether it was a social phenomenon. By social phenomenon, I mean some kind of phenomenon that takes place because of prevailing paradigm, technological and scientific. I wanted to know whether it was not just a radical epistemological skepticism, but there was something well-founded behind this hypothesis. So I started, right now I'm starting my timer late for the talk, just to make sure I'm within bounds, but I started studying philosophy of science. Now, I had a very good background in philosophy because I have taken numerous courses in the university. Every elective I could take was on philosophy, from classical to up to the analytic philosophy, logic. So I wanted to see, but philosophy of science is something different in many respects from traditional philosophy. So I wanted to understand whether the simulation hypothesis fitted in the whole framework. Before we go any further, I want to make sure we all understand that is one of the most abused words in science. When we say reality is, or a particle is, or mass is, energy is, force is, that or that, we are making a metaphysical hypothesis. And in most cases, when we referring to ontology of the reality, so we have to be very careful when we use this word in science, is. One of the most profound statements I have ever read in my research on philosophy of science is this one. Physical theories use mathematical models to link a primitive ontology to nomological variables. I said it was so obvious, but someone, Professor Allori, said it in a very beautiful way in this paper on the metaphysics of quantum mechanics. What does this mean? This means, to start with, that all theories make metaphysical commitments about unobservables, about things we cannot observe, but we make hypotheses that they exist. Then we use nomological variables. What are those? For instance, in Newton's second law, the nomological variable is momentum, and the law maps a hypothetical ontology, rather this nomological variable, to a hypothetical ontology. What is the hypothetical ontology? Particles, masses, energy, work, all these things, moving in space, exchanging interactions. So Newton's law is this type of law. It links a primitive ontology to a nomological variable. In quantum mechanics, for instance, the Schrödinger equation, the nomological variable is the wave function, and it links to a primitive ontology of particles and everything we have in quantum mechanics. Very profound statement, because it links to the following. Modern physical theories are underdetermined by models and data. So how do we accept hypotheses? They must generate new and relevant falsifiable predictions by experimentation. And we cannot prove theories are true, only falsify them by experimentation. This underdeterminism problem is well known in philosophy of science. Actually, for the same reality and same measurables, there are many theories that can produce the same result. Usually, scientists select the most elegant theory that satisfies these results and also the experiments. But note, pessimistic meta-induction problem. According to pessimistic meta-induction, in the future, all of our theories will be falsified. Of course, some people object to this, but I think it's reasonable. So, for instance, the other day I read the paper by Professor Bobson about the entropic force and the mass energy information equivalence. Now, this theory satisfies these two major assumptions of science. First, it generates new and relevant falsifiable predictions by experimentation, the annihilation experiment. And also it maps a nomological variable, which, as I identified, is the information mass through the entropic force to a hypothetical ontology, which is particles moving in space and the mass energy information equivalence. It was a beautiful result, not only because it's a new concept, but because it complies with all the requirements of what we call methodological naturalism. Methodological naturalism is the method used by modern science: theory, experiment, falsification. So don't do this for new people. Don't argue with people about who claim your theory is wrong. If your theory does not generate a new falsifiable prediction relevant to its claims, not just a general theory that hypothetically or even actually reproduces all the experimental claims of quantum mechanics, of general relativity, but it doesn't produce anything new, people will not spend 5 minutes looking at it, because in the paradigm we are now living, time is moving fast, and time is the most important commodity. So make sure if you have a theory, you can present an experiment that is directly tied to its assumptions, hypothesis, and also provide a law that links some nomological variable that can be tested or measured to some hypothetical ontology. Examples, some trivial examples: the pushing gravity hypothesis makes predictions that are falsifiable, and they have been falsified because a material graviton would create drag and heat up masses, so it didn't work, and those people pushing the pushing gravity hypothesis had to make it so small it became virtual and actually unobservable, so not to make these adverse effects. So actually it was another theory about unobservable quantities with no experiment to test it, because a virtual particle cannot be verified by experimentation. So people aborted the hypothesis, the intelligent design hypothesis, that the weak form claims that some parts of the humans are designed, and the strong hypothesis claims that the whole universe is designed, so it's covert creationism, is not a scientific theory because it doesn't produce any experiment. At the same time, the virtual reality hypothesis makes predictions that are falsifiable. Since antiquity, the big puzzle was universality of free fall. People have a misconception that we discovered the universality of free fall with Galileo. That's absolutely wrong. Galileo used knowledge from since antiquity and to support his experiments, whether they were hypothetical or actually did them from the Tower of Pisa. All objects, regardless of their mass or composition, accelerate identically in a gravitational field in vacuum or when no other force are present. Now imagine a world where universality of free fall does not hold. It's a mess. Just try to think about it. I will not spend any time on this particular aspect. Some experimental confirmation of the universality of free fall, John Philoponus, 500 AD, very well known that he did drops from tower. He had, of course, very small accuracy at the time. Galileo worked on the findings of John Philoponus and did either thought experiments or drops from the Leaning Tower of Pisa. Very brave man. He almost lost his life from his determination to prove scientific results. David Scott, hammer and feather drop on moon, and of course the most definite proof, the microscope satellite, metal cylinders in microgravity, high precision, weak equivalent principle. This is what has puzzled people from antiquity, since antiquity, about the nature of reality, because they were not able to deduce from the phenomena how universality of free fall emerged. There was no way. How is it possible? All the scientists, and they were neither smarter or we have more instruments, but from a rational perspective, they were not dumb. They knew what was going on. But a much bigger puzzle is motion. And this is not discussed because it is so fundamental. It really shakes the foundations of mechanics, dynamics, not general relativity, of course, because there is no motion. Actually, we will talk about that. And in some way, quantum mechanics. Motion has always been a puzzle. And Heraclitus said motion is fundamental because everything flows. So it's axiomatic, he said. But some scientists of the monism school did not agree. These people were not dumb, they were really smart. They said what exists can only be one and motionless. And Parmenides, and there is a reason the title is From Parmenides to Einstein, we will discuss about this later, because Einstein actually went back to Parmenides, but we will see how. What exists can only be one, motionless, indestructible, unchanged, finite, and indivisible. Very puzzling. So, what is the reality we are witnessing? Are you crazy? People said to the monists. Zeno of Elea, a student, Parmenides was student of Xenophanes, and Zeno was student of Parmenides. He was also an advisor to Pericles, the ruler that started democracy in ancient Athens. He said motion and change are illusions. And he used dialectics, infinitesimals, paradoxes, a list of 40 or more paradoxes. Now, the pluralists responded to this, that a beginning requires more than one, it's not one, and there is infinite divisibility, motion, change, no void. On the other hand, the atomists, and the most famous is the Lefkipus student Democritus, said no, the universe is and matter is discrete atoms and they move in voids. This has been adopted by modern science, leading to the foundational issues related to matter in motion, which are not discussed. They are discussed only in philosophy of science circles and papers, but in the books, in the school curriculum, the students learn that there are these atoms, that they move in space and in voids, related stories. So what is the matter in motion and particle in motion problem? It was described very nicely by Butterfield, Jeremy, I think his name. He's a professor at Cambridge, I think. At this point in time, I think the UK has the best philosophers of science. The matter in motion picture is problematic for whether we conceive bodies as swarms of tiny particles or as made of continuous stuff. There are troublesome questions about how bodies interact, and I have the link. That science does not explain. So let's see what some notable figures thought about motion. Parmenides said it's an illusion. Aristotle said it's an absolute realization of potential. Philoponus went against Aristotle, and he said it's an absolute intrinsic tendency. Descartes said it's relative geometry, extension, and math. And now we start the isms, you will see. Descartes' ideas evolved into what is called occasionalism. We will talk about it later because my hypothesis is based on this. Leibniz, one of the probably most important philosophers of all time, said it's a relative phenomenology. And he called relationism. Now, occasionalism and relationism are also called mechanism and dynamism. So, more isms. Newton said it's a change in absolute space and time, and it is called substantivalism. Substantival space and time, they exist independently of the events in them. They are like a container where all the phenomena take place. Einstein, it's very complicated. He said change in space-time, four-dimensionalism or relativism. Now relativism and relationism are completely unrelated. Actually, relativism, it's a paradoxical theory that relates to absolutes. And it's very hard to get into this in this presentation, but initially relativity theory was called the theory of absolutes. So let's move to the next slide. Xenophilea, the monist, attacked pluralism and discrete atomism because they were both easy targets. He said motion is an illusion because it cannot start, and nothing can perform infinite many tasks. Motion is a super task. I have a reference here. In schools, people learn it wrongly. They say motion cannot complete. This is not true. It's obscurity obscurantism, they are obscuring the problem, because Zeno said, if I start at S, there is a small infinite distance to cover, or like this, but before that there is half of it and half of it and half of it and half of it, infinitely many ad infinitum. You cannot even start, not that you cannot finish. But mathematicians said, okay, because of this, you can finish, so let's forget it, which is a series convergence, and later they used no standard analysis, but mathematicians did not rescue physics, because Zeno's argument was about motion in a plenum and not about mathematical series convergence. Let's not spend more time about this, it can take 2 hours of discussion. The arrow paradox is even more interesting because it attacks discrete atomism and motion in a void, the prevailing paradigm in modern science after Cassendi revived discrete atomism and Democritus, because it said simply it is impossible for one particular thing both to have and not to have some feature, in this case the void, and as a result a change from having one feature like the state of the void to not having it and becoming part of an arrow, which is also impossible. Motion in a void is an illusion because it cannot start. Aristotle had a rebuttal, and he said, as an empiricist, since motion is a phenomenon of experience, Zeno's argument is a dialectic. And Zeno rebuted Aristotle by saying the phenomenon of your experience is an illusion. The search for the true nature of the world died in Elea 2500 years ago. So scientific realism, which assumes that there is an independent reality from and our theories are approximately truth, died in Elea, and since then scientists have transitioned to models, and that started with natural philosophy in the 17th and 18th century, and what questions can we ask and what model can we build that best describes the phenomena, because we cannot know the true nature of reality. It's surprising though that even nowadays 75% of the scientists are realists, as Gallup say. Now an even bigger puzzle, force. The idea of force as the cause of motion should be discarded, since the assumed cause and effect relationship cannot be proven. This was in my test, Principle of Dynamics, graduate test. In the text, in the introduction, of course, most people do not read the introduction, and there the author, Donald Greenwood, explains why force is an intellectual construction, although in the curriculum in high school and college, people get the students the idea that there are things, that there are forces, but no one has ever seen a force. So Parmenides, force is an illusion. Aristotle, sustained action by a medium. Philoponus, impetus to resistance from medium. Descartes, inertia contained in the medium. Leibniz, living force, vis visa, mv square, medium is irrelevant. Newton, inertia a force, By the way, Newton never expressed the law, the time rate change of momentum, and also never expressed the law mass times acceleration. It's in my book, Beyond Intelligent Design. It's another long discussion. For Einstein, there are no forces, it's geometry, medium is space-time. Einstein was eclectic, he went back to Descartes, but he took some ideas from Newton, and through four-dimensionalism he finished his theory, which was very successful. Now, Einstein metaphysics, they have called the Parmenidian by many famous philosophers of science, a causal and eternal universe where existence is due to sequence of space-time events, also called processes, a very strange word. Leibniz and Newton's words are not well founded philosophically and empirically. A virtual reality may be a better alternative to Einstein's Parmenidian reality. What did Einstein do versus Newton? There are two things that are fundamental: free will and determinism. If you have determinism, you do not have free will because everything is determined. If you have free will, you cannot have determinism, you lose the autonomy of the world. So Newton decided that autonomy of the world was more important than free will, essentially, with his laws at this. On the other hand, Einstein said, for me, free will is more important than autonomy of the world. So, actually the other way around. Einstein is, there is no free will but autonomy, and Newton, it's free will but not autonomy. Descartes, he said, I existed a little while ago, I exist now, a lifespan can be divided into countless parts, it's completely dependent on the others, I experience no power of creating myself. He was fighting his demon. Therefore, there is some cause which, as it were, creates me afresh at this moment, that is which preserves me. This is very profound. It is not taught in schools. Very underappreciated time in human science. And then his followers, like Nicolas Malebranche, formed the Cartesian occasionalism doctrine. What we actually call causes are really no more than occasions on which, in accordance to his own laws, God acts to bring about the effects. So what do we have here? We have the first hypothesis of some computational universe of some form, but during that time you couldn't say mechanism because you would end up in a 2x2 cell for the rest of your life. You had to say God. You understand this? So if we replace God by mechanism, this is what my modern occasionalism doctrine, what we actually call causes are really no more than occasions on which, in accordance to his own laws, a mechanism acts to bring about the effects. I wrote about this in 2005, and when I started publishing a few things. Now, time emerges from the actions of a mechanism as an ordered progression of instances or nows. Gravitation and motion are emergent phenomena and have external cause. the mechanism is the space-time. So this is substantivalism. So all this is metaphysics, okay? All this is metaphysics. So I came up with this term functional virtual reality. The space-time exists independently. It's a mechanism that creates all the phenomena via intelligent interaction and possibly a super solid medium. You see, I don't like analog versus digital. I think it's a false dichotomy. I think a very sophisticated reality of the type we live in will neither pick analog or digital, but something else. But digital helps us to model some things, but I doubt that the true nature of the world is some grid or pixelized space. It's something more complicated. But all this is metaphysics. Reality and effect, but also part of the mechanism. The mechanism can exist without creating any reality. Now I wrote a paper, Power as a Cause of Motion, because force is not the cause of motion, for sure, everybody admits. And I claim that I can derive all Newton's laws from power, which is the rate of change of, the time rate of change of kinetic energy. What is difficult here is that power is a scalar, so it doesn't give you direction. So how does the direction arise? Because, for instance, motion on a circular path, like an orbit around a star, the cause is zero. It's inertial motion according to this law. So how the motion arises? Well, Newton had the same problem. He said, my law of gravity, which was not his law of gravity, of course, it was invented by a guy named, I think, Ismail Bouyal, the inverse square law, and Newton was asked to prove that he generates the motion of the planets. And he did, and this was his major contribution. So how does a scalar? Because there is a mechanism, and the mechanism decides which motions to take place and which motions not to take place, and also imparts free will. And this is the idea of from power, because of course from energy, you know, Lagrange equations, you can derive the equations of motion and everything. I think power is more fundamental than force. Actually, is the fundamental. Everything takes place because of exchange of energy and the rate of change of energy. And there are no forces, basically. Causality, causes are occasions on which the mechanism acts to bring about the effects. Occasionalism, I borrow the idea, I didn't invent anything. So free will, free interactions are allowed within the limitations of the physical laws. So we have this equivalence principle of reality and functional virtual reality. A functional virtual reality, which I may call it a functional reality from now on, because I have started not to like the term virtual, because mainstream media is using it, that imposes physical laws in terms of virtual quantities is equivalent to a reality. So this is a reality. Even if there is computational universe, this is the reality. And actually, the universe is part of this reality. So it's an all-encompassing entity which we can call the reality. examples of laws, Newton's law of gravitation and second law of motion, are expressed using virtual quantities. Corroborating experiment, detection of violations of this equivalent principle. Can we find occasions on which the mechanism is unable to bring about the expected effects? So what am I saying here? I'm looking for a brute force falsification. I'm not trying to do any quantum experiments because the results, they can fit it in any of the 600,000 interpretations, actually 15, but so it's a brute force experiment. Will it work? Probably no. If you tell me that it will not work, I will agree with you. So don't try to convince me. Some experiments that they have, we cannot talk now, we're running out of time, we have to wrap this up, but some experiments that they are alleging falsification, actually they do not, and some of them, like speed of light variation, quantum speed limit, update cycles, so information density, they support the idea of probably the universe having computational limits, a quantum speed limit, Planck time, speed of light, maximum energy per particle, quantum information limits, but there is a suspicion that if there is a limit, computational limit, it is likely faster than attoseconds, 10 to the minus 18. So it's a huge limit. And also there are other considerations. For instance, the space-time, computational space-time may be so intelligent that when it requires local resources, it reconfigures itself. So we may never able to prove it, but Thomas Campbell has some quantum rendering experiment, inconclusive. I have trouble with the experiment because introducing the idea of consciousness, no one knows what consciousness is. There is no clear definition. So I would like to talk a little bit about the experiment, but we don't have time. A more promising experiment is Dr. Vobson's annihilation experiment, funding stage. I'm not sure he's pursuing it. The Malebranche machine I introduced in a paper in 2011, and it's a brute force experiment. I'm not sure it will work, but the general idea is if space-time is a mechanism and the cause of all phenomena, it is possible that there are local computational limits. Maybe there are none, okay? Don't try to convince me, I will say probably you are right. The objective of the Malebranche machine is to amplify the demand for computational local resources and attempt to detect computational limits when a suitable mathematical processor operates in an environment of high disorder. Very ambitious general idea. When there is no disorder, the output should be expected statistically as expected. If the output variations are statistically significant, when there is high disorder, then we may have a corroboration of the hypothesis of virtual reality. Note that we can never prove it. We can corroborate it, and some smart people may come back and say, you know something, there is an auxiliary hypothesis in our theory, and that explains this, so it's not a virtual reality, something else, but we can try. So this is the general idea. We put some flow, disorder, mathematical processor. Some more details. of the Malebranche machine, and we're gonna wrap it up in 5 minutes. We pump helium with we have bluff types. This is like a small wind tunnel here. We have grids, bluff types, pyramids, disks, and we have a tiny math processor. This is a tiny machine, and the cost is inversely proportional to size, of course. And we got a high Reynolds number, lots of disorder. That's why I chose helium. It has the lowest mass after hydrogen. Hydrogen is not good for this type of experiments for obvious reasons. We don't want a high blockage ratio. And initial phase, a 4-bit synchronous up counter with a gate all around, nano computers, 2 nanometer lithography, probably around 250 to 200 gate all around required. It's similar to the design to the well-known chip I state here that is used in industrial applications and other counting applications. We need recording media, interface, power supply and cooling. We want to be as close as possible to quantum tunneling when particles behave like waves, but we don't want to ruin the experiment. So 2 nanometer technology is available in Taiwan, Samsung, Intel. 1 nanometer is experimental in Berkeley and IBM. Note that the size of the atom is 0.1 nanometers. Experiment requires collaboration of various disciplines and may cost up to 3 million. And the next stage, if this works, because you know the nano transistors we may have a lot of false countings, so it will be a statistical experiment. You're going to reject the null hypothesis. Multiple arrays of cascade counters, a chip with millions of gate-all-around transistors, less than 2 nanometer lithography, with interface, power supply. Experiment requires all these disciplines and a lot of money, cost maybe more than 10 million. But I said the AI burns around $1 billion every day to give you LLMs to undress politicians and put them in bikinis. So why not spending 10 million, and we may not prove it's a virtual hypothesis, we may learn some other things along the way. So if you tell me this experiment will not find anything, don't try to convince me. I will agree with you immediately. So I just gonna do it because I'm curious, and it's expensive though. Curiosity is very expensive in science. Summary, thank you for those who got so far in this talk. If an external reality running computation is causing the phenomena in our world, there may be computational local limits, there may be none, okay, it may be so smart and so reconfiguring itself that there are basically infinite powers, so we will find nothing. We may attempt to detect, experiments may become too expensive, the experiments are a long shot. Never trust a person who comes to you and say the experiment will prove something, okay? One in 1,000 experiments prove something. The most probably outcome is no detection of anomalies. The goal is corroboration of the virtual reality hypothesis. The virtual reality hypothesis cannot be verified. We may have to stay with rationalism, Descartes, Zeno, and just be realists during the week in our job and science, and anti-realists during the weekend only. So this is my blog. You will find, I have many articles there. There is a free book from Aristotle to Konrad Zuse. you can download that. Also, there is a link to my book, Beyond Intelligent Design, from an autonomous universe to a functional virtual reality. And some articles, I don't update it now often. I stopped actually working on the virtual reality hypothesis around 2012, 2013. I learned what I had to learn. My salary did not depend on understanding anymore. So actually it didn't depend at all. So maybe in the future I will work on a hypothesis that assumes a totally material independent world because I have an idea, but I'm not sure if I find the time. Thank you for listening, and thank you, Dr. Vopsu, for the invitation.
Efthimios, thank you for your time and for this nice presentation. I'm quite keen to ask a few questions. Let's meet all of us in the chat room, live chat room. There are already colleagues waiting there already. They already joined. So I'll see you all in 2 minutes in the chat room. Thank you, Efthimios, and see